Okay, question 7 is a bit of group 7 knowledge and a little bit of just sort of forgetting a pattern from the periodic table. And this is a slightly dodgy trend, to be honest, because you can't assume necessarily there's a straight line between the boiling point of chlorine, bromine and iodine, but the easiest, sort of safest thing to do would be to go in the middle, but you're allowed anything between 40 and 110 degrees. So if you just guessed about 60 degrees, that was fairly sensible. I need to know that fluorine here is a yellow gas, which is an easy 2 marks if you knew it. Part C is about redox, and really you just need to know what a redox reaction actually is. Redox means that you have oxidation and reduction occurring in the reaction. Oxidation means to lose electrons. Reduction is to gain electrons. Looking at the chemical equation, is it easy to see what's gained or lost electrons? Not really, but if we just try and focus on it a little bit, the bromine, okay, starts out just Br2 and it turns into Br minus. So that is reasonably easy to say has gained electrons. The iron, okay, goes from Fe2 plus to Fe3 plus. If it's become more positive, that means in order to get more positive, it must have lost some negative electrons. So that's lost electrons. And to get the marks of the question, you just have to say that Br2 is oxidized and Fe2 plus, sorry, other way around. So to get the marks of the question, you just have to say that Fe2 plus undergoes oxidation and Br2 undergoes reduction, i.e. the bromine gains electrons and the Fe2 plus loses them. Slightly odd question here again for 6 marks, expecting you to think about how you would work out if Fe2 plus reacts with chlorine. So if you think about it, you could just have a solution, let's draw a beaker of a solution containing Fe2 plus ions. Okay, if you could either add chlorine dissolved in water or you could bubble in chlorine gas to that. And that's basically the method, just 1 mark for each bit of add chlorine water or chlorine gas to Fe2 plus. You had to state the formula of the Fe2 plus compound, so you couldn't just say Fe2 plus, you can't get Fe2 plus ions on their own. So this Fe2 plus must come from any compound that contains Fe2 plus that will dissolve in water. If you think about what always dissolves in water, easiest thing to do would be to say nitrates. So iron 2 nitrate dissolved in water would got either solution and that mark. Then to show if the Fe2 plus has reacted, well, you could either say after you've added the chlorine, you can test for Fe2 plus. To test for Fe2 plus, you could add sodium hydroxide. And if you get a grey-green precipitate of iron hydroxide, you've still got Fe2 plus and it hasn't reacted. If, however, it does react, you'd expect the Fe2 plus to react in exactly the same way as it did up here and turn into Fe3 plus. So if you formed Fe3 plus, okay, so that would be like a negative result with the Fe2 plus. If you formed Fe3 plus, you could say, well, you can react that with the same sodium hydroxide, and you'd now end up with the reddish brown precipitate of iron 3 hydroxide, and that would tell you that the chlorine had reacted with the Fe2 plus. So this is your green precipitate, that's your red-brown precipitate from the positive test. Then a suitable safety procedure, well, the big issue with this, particularly if you've chosen to use chlorine gas, is that the chlorine gas is toxic and you should use a fume cupboard. You might also mention that the sodium hydroxide used requires you to wear safety glasses. In reality, if you sort of try and link your safety precaution to one of the chemicals, if at all possible. Part D asked for a dot and cross diagram for chlorine oxide. If you think about it, the oxygen always forms two bonds, chlorine forms one, so the oxygen had to go in the middle. If you just do the outer shell, oxygen, if it's forming two bonds, then it's going to make an overlap on both sides with the chlorine and form a single bond with each one. So that was effectively 1 mark. Then just thinking about it, the fact that oxygen has 6 electrons in its outer shell means there must be another 4 to draw in. So we've drawn 6 crosses in total. Chlorine in total has got 7 electrons in its outer shell. I've just drawn 1 electron for each chlorine, so I can add in the other 6 electrons on each chlorine atom, and that completes the full outer shell for each atom and gets me 3 marks. The second part of this question is about the pH of solutions formed from oxides, and the basic rule here is that non-metal oxides like chlorine oxide form acidic oxides. So any sort of acidic solution, remembering that a pH of less than 7 is acidic, because chlorine is a non-metal. The flip side of that would mean that any metal oxide should form a alkaline solution. So if the question had magnesium oxide or calcium oxide or sodium oxide, and it asked about that dissolving in water, you'd expect that to be alkali because those are all metal oxides.